Hey guys, today we are looking at our notes for 1.3, which is all about adding and subtracting fractions together. Yesterday we did 1.2, which is just the basics of fractions, kind of reminding us how they work, what their setup looks like, how to simplify them. Today, obviously focusing in on adding and subtracting them together. So for this first part here, I've got a step-by-step guide on how we do that, how we add two fractions together. Depending on what your problem looks like, you may or may not need all of these steps, or depending on what your answer is. But at least the whole list is here in case we get as ugly as there is possible for us. So when we're adding them together, our first step is going to be making sure that they are just single fractions. So either a proper fraction or an improper fraction. We don't want to try and work with mixed numbers. I just want a single numerator and a single denominator. So a lot of the problems might already be that way, but if we do have any mixed numbers, first thing we would do is rewrite it as an improper fraction. The step 2 is finding a common denominator. So we need to find, in order to add or subtract two fractions together, we need to have the same denominator. So that bottom number in my fraction has to be exactly the same. So when I do that, there's a couple of different ways that you can find the common denominator. What I suggest to try and save you some headache in terms of simplifying afterwards is finding what we call the least common denominator, the LCD. So the LCD is the number that is the smallest number, the least common denominator is the smallest number that both of my denominators are factors of. And I'll kind of show you what that looks like. We'll do a lot of examples together once we get into it. That, I think, is going to be the step that most of us struggle with if we have a place where we're going to struggle. The rest of it, I think, is a little easier, but getting them to have the same denominators is the part that's the difficult part. So once we have those, we're going to just rewrite those using the same denominator, add them together or subtract them, the numerators together with the same denominator, and then simplify as needed. So jumping into this first example for number 1, if we have 1/10 plus 3/10, well, if we just add those together, because they already have a common denominator, they're both in terms of 10, their bottom is 10. So all I have to do is then add the numerators. So 1 plus 3 is now over 10. Combine them together. That gives me 4 over 10. So the last step, and you kind of see it peeking there at the top of the screen, step 5 is simplify as needed. This one does need to be simplified since both top and bottom are even numbers. I can divide top and bottom by 2. Divide by 2 on top and bottom. And my answers should be 2 over 5. 2 over 5. So like we did yesterday, I'm just going to do one row. I'm just going to do the odd problems, and then I'll go back and show you your answers. So if you want to have those extra practices, you can do that. So for number 3, so if we go through, I'm not going to keep scrolling back and forth, but you guys have the full page in front of you. If you look at step number 1 in our set of steps necessary for adding or subtracting, step 1, write all mixed numbers as improper fractions, which is done. They're both just single fractions, they're not mixed numbers. So step 2, I need to find a common denominator. So there's like I said before, there's a couple of different ways that you can do this. You're trying to find the smallest number that both 10 and 15 go into. So one of the ways that you can do this, if it doesn't just pop into your brain, you could factor out, like find what my prime factorization is. So you could look at what numbers multiply to get 10 and 15. So like in this case, 10 is 2 times 5, 15 is 3 times 5. The least common multiple, the LCM, which is going to be our least common denominator, just has to include everything that shows up. So I see a 2, a 5, and a 3. I know I see 2 5s, and it shows up in each of them. But in this case, I see those together. If I multiplied all 3 of those together, that would give me 30. Right? 2 times 5 is 10. 10 times 3 is 30. So 30 is my LCD. My LCD is 30. That means 30 is the smallest number that 10 and 15 are both a factor of. So once you know what your LCD is, you're going to rewrite that in terms of the LCD. So I'm going to change my denominators to 30s. Now, in a fraction, like we did yesterday with reducing, I can divide top and bottom of my fraction by anything I want to, as long as I do it the same on both top and bottom. I can also multiply on top and bottom, as long as I'm multiplying by the same thing. So in this problem, if I wanted to change my first fraction, which is 3 over 10, to have a base of 30 instead of a base of 10, I would have to multiply. I'm going to erase this stuff to clean it up a little bit. If I wanted to change my 10 into a 30, I would have to multiply it by 3, right? Because 3 times 10 is 30. But if I multiply by 3 in my denominator, my numerator also has to get multiplied by 3, because I have to multiply by the same thing on both top and bottom. So that tells me that my first fraction, if I change my base to 30, would be 9 over 30. If I do the same thing with my second fraction, 15 times 2 would be 30. That would give me my common denominator of 30. So if I have to multiply by 2 on the bottom, I have to multiply by 2 on the top, and that gives me 22 out of 30. From here, it becomes the same problem we were just working on. I just have to subtract those two in order to combine them together. So 9 minus 22 all over 30. I do that subtraction like we did in 1.1, and I get negative 13 over 30. Okay, so number 5, take a look at the next one. This one, the same rules apply to subtracting a negative fraction, just like it did subtracting a negative number, just regular number. In number 5, since I'm subtracting a negative, we're going to rewrite that as just addition. So instead of having to subtract a negative, this is the same thing as 2 over 9 plus 5 over 18. So once I've done that part of it, makes it easier to look at it as an addition. So now I have to just find an LCD, because they're both already proper fractions. I just need to find a common denominator. Now, a lot of us, as we go on, we'll get better at picking out what those numbers are. The more practice you do with these, the more you get used to seeing what common denominators are and identifying what factors they have in common in order to get a common denominator. In this case, my two denominators are 9 and 18, which hopefully is a little more obvious to us because 9 times 2 is 18. So I can rewrite that first fraction in terms of a denominator of 18 without having to change the second one, which is totally fine. You are able to and allowed to do that. So I'm going to go ahead and do that. I'm going to multiply top and bottom of my first fraction times 2, because that's going to give me 4 over 18. I didn't change anything about my second one, 5 over 18. I can add those together. 4 plus 5 over 18 gives me 9 over 18 for my answer. Now, obviously, I have to reduce that because that does simplify. Top and bottom are both divisible by 9. And I end up with a half. 1/2. All right, number 7. We got finally a need to use step 1 in our list of steps. So step 1 is rewriting any mixed numbers as improper fractions. So we're going to go ahead and do that first. Remember, when we're doing that, like we talked about yesterday, we take and multiply our whole number by our denominator. So 2 times 8 is 16. And then we add the numerator. So 16 plus 3 is 19. So this is a negative 19. My denominator stayed the same, 8. For my second fraction, I know it's subtraction, so I can do that. 1 times 4 is 4, plus 3 is 7. So 7/4. So I've got negative 19/8 minus 7 over 4. Again, you're trying to figure out what's the smallest number that both of these are a factor of. Well, again, 4 times 2 is 8, so I can turn them both into 8s because the first one is done already. So I'm going to multiply by 2 on top and bottom. That gives me negative 19 over 8 minus 14 over 8. So negative minus 14, that's going to make it a bigger negative, right? If I'm starting at negative 19 on the number line and I subtract 14, I'm moving 14 spots further to the left. So I end up with a total of negative 33 eighths, which I'm fine leaving it that way. If you want to, because you are given your problem in mixed number form, you can give your answer in mixed number form. If you want to do that conversion, remember we're doing how many times does our denominator evenly go into our numerator. So in this case, 8 goes into 33 4 whole times with 1/8 left over. So you also could have your answer as negative 4 and 1/8. Either of those are fine. I usually just leave it as an improper fraction unless the instructions explicitly tell you that you have to put it as a mixed number. I'm fine leaving it as a improper. All right, so the other ones, like I said before, if you want to practice these on your own, you can pause the video, do the even numbers, and then just check your answers. So if you did that, or I guess after doing that, for number 2, you should have gotten 11 over 12. For number 4, negative 25 over 4, or negative 6 1/4 if you put it as a mixed number. 6 should have been 23 over 40. And then number 8, either 55 over 12, which is 4 7/12. 4 7/12. Okay, a couple more examples here, just 2 more, and then we'll get into some application problems. So with number 9, we've got 2 4/5 minus a negative 2 1/4. So I'm going to kind of kill 2 birds in one stone. I'm going to do 2 steps in one, so hopefully that doesn't confuse you or get you lost. Because I see here that I'm subtracting a negative, which I'm going to go ahead and I can rewrite that as addition, right? Subtracting a negative is like adding. But I'm going to rewrite that as addition. At the same time, I convert these into improper fractions from my mixed numbers. So to convert 2 4/5 into an improper fraction, we would do 2 times 5, which is 10. 10 plus 4 is 14. So 14 over 5. We know now that that's plus since we were subtracting a negative. 2 1/4, if we're trying to rewrite that as an improper, 2 times 4 is 8, plus 1 is 9 over 4. So that big ugly problem became 14 over 5 plus 9 over 4. So option number 3, haven't really talked about this, in finding a common denominator. I know the instructions say to find a least common denominator. We're looking for the smallest number that both of them are a factor of, but sometimes it's easier to just multiply by the opposite denominator. In this case, that actually does give us the least common denominator, but if I need to have 5 and 4 as a factor, you could just multiply those 2 numbers together to get 20, and 20 is a common denominator. So you don't necessarily need to have the least common denominator. You could just find a common denominator, and the guaranteed way of doing that for every single problem is just by multiplying by the opposite denominator, multiplying my 2 denominators together. Now in this case, that actually does give us the LCD, but that's not always the case. So here, I'm going to multiply top and bottom by 4, since that's the other denominator. And then here, I'm going to multiply top and bottom times 5, because again, that's the other denominator. Both of my denominators are going to be 20 after I do that. Up top, 14 times 5 is 56. 9 times 5 is 45. So if I add those 2 together, 56 plus 45 is 101. So 101 over 20. If, again, you want to be a mixed number person, 5 and 1/20. Should be my final answer. Okay. So for number 11, Same thing. Step 1, convert any mixed numbers into improper fractions. So just the second one here. 1 times 9 is 9, plus 2 is 11. So I can rewrite this problem as negative 5 over 6 plus 11 ninths, 11 over 9. So this is a good example of what I was just talking about. The least common denominator here is 36, right? Because 6 times 6 is 36, 9 times 4 is 36 as well. So if you recognize that, that's awesome. That's the least common denominator. But if that's not something that you're comfortable with, if you're kind of struggling with that, obviously keep trying to figure it out, because a lot of this just takes practice. But the other thing you can do, it's not going to give you the least common denominator, but it's going to give you a common denominator, is just multiplying by the other denominator. So it's not going to give me the LCD, but it's going to give me a CD, a common denominator. I can multiply the opposite denominator on top and bottom. So I can multiply the first fraction by 9 on top and bottom, and the second fraction by 6 on top and bottom. So when I do that, I get negative 45 over, 54, plus 66 over 54. So even though it's not the least common denominator, it is still going to be the same denominator in total. So when I go ahead and combine these together, I end up a negative 45 plus 66 is 21 over 54. So when I reduce this, I can divide top and bottom by 3, because this is something that is reducible. I can divide by 3 on top and bottom, and you end up with 7 over 18, which would be the same answer as if you did it with the least common denominator of negative, or of 36. So if that helps you, that kind of removes one decision in the process to just multiply by the other denominator to get a common denominator, then that's totally fine. If that works for you, then keep doing that. If not, and you're able to pick out what those least common denominators are, then that's awesome, and keep doing that, because it's going to make it easier when we have to reduce. All right, 10 and 12, like I said before, if you want to pause and try the problem on your own, but I'm going to go ahead and throw the answer up here so you can check it. Number 10 should have been 13 over 48, and number 12 should have been negative 15 over 4, which is negative 3 3/4. All right, last problems here, 3 more. So these last 3 problems, these are application problems, which is also another word for word problems. They're given us in the description, but it's because there is some application to it. It's some scenario or some situation that you may or may not encounter in your real life that utilizes these ideas or these concepts. So for number 13, we're given or told that the length of a board is 2 5/8 feet long. If we trim off 5/6 of a foot, they want us to find the new length. So sometimes it helps to draw a picture. Sometimes you can just follow it along. In this case, they tell us that we're trimming the length off, which means we should be doing a subtraction here. If our original board is 2 5/8 inches long, 5/8 feet long, we're subtracting off 5/6 of a foot. They want us to figure out how long the board still is after we trim that off. So that's what our problem should look like. That should be how we set it up. We have that subtraction, 2 5/8 minus 5/6. So from here, it's just the same process we were doing. Start by converting any improper or mixed numbers into an improper fraction. 2 times 8 is 16. 16 plus 5 is 21 over 8. And then my 5/6 was already a proper fraction. So now I have to find my least common denominator. So If you find the least common denominator, it should be 24 in this case. 24 is the smallest number that both of these can be rewritten as. Right? 8 times 3 is 24. 6 times 4 is 24. So I'm going to multiply first one times 3. My second one times 4. That's going to give me 63 over 24 minus 20 over 24. Whoops, 20 over 24. So when I do that, that gives me 43 over 24. So you can leave it like that. Improper fraction is fine. In this case, since it's describing a length of a board, it might make more sense for us to put it as a mixed number. So 24 goes into 43 just once, with 19 left over. So 1 and 19 24ths feet. Either of those two, totally fine. But notice here, since it's an application problem and I'm given units, I need to make sure I include those units in my answer. All right, next one. During a recent 2-day snowstorm, it snowed 6 1/8 inches on the first day and 8 5/12 inches on the second day. They want us to find the total snowfall. So this one, hopefully easy to see that we're just going to be adding these together because I want to find the total snowfall between both days. So I'm just going to add day 1 and day 2 together. So we've got 6 1/8 inches plus 8 5/12 inches. Lots of snow. That's quite a pair of days there. So step 1, mix numbers into improper fractions. 6 times 8 is 48, plus 1 is 49. 8 times 12 is 96, plus 5 is 101 over 12. So you can either multiply the first fraction by 12 on top and bottom and the second fraction by 8 on top and bottom to make the common denominator. It's a whole lot easier because, once again, both 8 and 12 go into 24. Right? 8 times 3 is 24. 12 times 2 is 24. So I can rewrite that, my two fractions, as 24ths. So 49 times 3 is 147 over 24. 101 times 2 is 202 over 24. I add them together, and I get 349 over 24 inches, which, if we want to convert that into a mixed number, probably have to use a calculator for that. So 24 goes into 349. Obviously, use a calculator, divide 349 by 24. It goes into it 14 whole times, which gives us 13 24ths left over. But again, either way, if you don't want to convert it into a mixed number because you don't care to know approximately how many inches it was in total, that's fine. All right, so our last one. Natalie is baking a cake and cookies for her daughter's birthday, or for her daughter's class party. She needs 1 2/3 cups of milk for the cake and 1/2 cup for the cookies. They want us to figure out if she is given that she has 3 cups of milk total, how much will she have left after she has cooked both of those things. So you've got 2 different ways that you can approach this problem, because you're starting with three cups of milk. So we've got this whole big container of lovely milk. 3 cups of it. You're going to use some of it for the cookies. You're going to use some of it, let's just say cookies. This one is going to be for the cake, but you're still going to have some left over. So you can do this one of 2 ways. You can either do 2 subtraction problems, start with 3 cups and subtract off 1/2 cup for the cookies, and then subtract off 1 2/3 for the cake. Or you can combine your 2 recipes together and then just do 1 subtraction. So that's how I'm going to do it. I'm going to figure out how much milk she's going to use between both recipes first, and then subtract that number from 3. But as always, it's up to you on how you want to approach the problem. There's 2 different ways of doing it. So to figure out how many cups she's going to use, I'm going to put a D at the end there, cups used, we have 1 2/3 plus a half. That's going to tell us how much milk she used for her 2 recipes. So convert to a mixed number first. 1 times 3 is 3, plus 2 is 5. So 5/3 plus 1/2. Converting that to a mixed number, I can turn them both into 6s, top and bottom. There we go. So 2 times 5 is 10 over 6. 1 times 3 is 3 over 6. So in total, she's going to use 13/6 for her 2 recipes. So if that red number, 13/6, is how much she's going to use for the 2 recipes, I can go ahead and just make a little dotted line here. If I'm trying to figure out how much milk she has left after she uses it, I have to do my 3 cups minus that 13/6 that she's going to use for the 2 recipes. So this one a little weird because we haven't seen a whole number like this. There was one on the even problems, but we skipped that one. Remember that if you're trying to write it as a fraction, if you're trying to write a whole number as a fraction, you can always write it over 1. Right? Because like we talked about, a fraction is just a division. So 13/6 is the same thing as 13 divided by 6. So 3 divided by 1 is still just 3. So that's how I would make it. So I would kind of force it to be a denominator. But from here, if you're trying to just combine the denominators together, I have to find an LCD. My denominator is 6. So I'm just going to multiply top and bottom of that second fraction by 6. That's going to give me an LCD of 6. So 18 over 6 minus 13 over 6 tells me that after she is done with her recipes, but making both the cookies and the cakes, she's going to have 5/6 of a cup. All right. That is all I have for you guys for today. So as always, if you guys have any questions, concerns, thoughts, ideas, hopes, or dreams, make sure you guys are reaching out and letting me know. Otherwise, have a fantastic day. We'll see you soon.